This conference will now be recorded.
Hello, good morning, sir.
Good morning.
Sir, yesterday's class I have one doubt.
The
This
file in the user
conference
home,
will now be recorded.
or you are creating the file under the slash. What is the difference? Let's say you created the file in the Alex user home directory. In that case, only this user can able to access that file by default. By default, only that user can able to access. Or else, if you created the file under the slash root, under the slash directory, all the users in the system can able to access. Because this is the system wide location and this is the user home directory. Just simple example, if you have the money in your account, only you can able to access through the ATM. If you have the money in the ATM, anyone can able to access, right? That is how. Just make the difference. And also just try to understand, there is the difference between the root. This is also we are calling it as a root directory. Don't confuse this slash directory, also we are calling it as a root directory. But what is the difference between the root directory and root user home directory? Root user home directory is just like a normal user home directory. If you created any file inside the root user home directory, only root user can able to access. Or if you created any file or directory inside the root directory, all the users can able to access. Don't confuse, this is the root directory, this is the root user home directory. Okay, that's fine. See, absolute and the relative path, let's try to understand this. Let me come to my terminal. Let's say here I created one directory, the directory name is, what happened to this project. I created the directory, the directory name is project. Now inside this directory I have one more directory. Inside this project directory I created one more directory, just name it as new project. So let's get inside this project first. So now I want to change my directory to new project. Where that new project directory is located? Inside the project, the new project directory is located. In that case, directly we can use the CD and the directory name. Then you can easily go inside that project, right? Let's say this time I'm in some other location. I'm in the user home directory or some other location. This time I want to move to new project directory. Then how we can move inside that directory? First, one thing is, first we can move to project directory, and after that we want to move to new project directory, right? But just try to understand this. The new project directory is located inside the project, is it? So after that, after the project, we are specifying the slash. So the file which is started with the slash, that is the absolute path. It means here you are specifying the complete path. Okay, your new project directory is not located in your current directory, it is located in some other directories. In that case we are specifying the complete path. Here in this example, from the project directory we change the directory to the new project. Here it is a relative path. It means the current changing directory is in current directory, but in this case here we are specifying the complete path. You can use in this way, and also you can specify the in this way also, right? Both are same, because the file which is started with the slash, here you are specifying the complete path, so it will take you through the same new project directory. That is absolute path and the relative path. Simple. The location which you are specifying from the slash, that is the absolute path. The location which you are not specifying the slash, that is a relative path. Why we are specifying the slash? It means everything will be stored in the file system hierarchy. And also just type ls space hyphen I. So when you type the hyphen I, here it will showing the numbers along with your files and directories, right? So what are these numbers? These numbers we are calling it as an inode numbers. In your system assigns one unique inode number to each file and directory. Okay, it's assign one inode number to each file and directory. See, when you format every directory, whatever we are storing, everything will be stored in the slash directory, right? So here the slash directory is formatted with the file system that you will know in the storage. As of now, just remember this is the file system. Formatted with the file system. Whenever you are formatted your partitions with the file system, for tracking and security purpose, it is assigning an inode number to each file and directory. But what exactly this inode number contains? Whatever the information you are having on that file. Let's take one simple inode number. Let's li project. Let's take this directory. So every file in your system having privileges. The very first one is the privileges, basic privileges we can say. After that, number of hard links. After that, owner of the file, group owner of the file, and the timestamp when this file is last modified, and the name of that project. Okay, this inode number contains all this information. This inode number contains all this information. By default, your directory cannot store any files and directories inside this. Remember that. Let's say a new project we created in the root user home directory. That root user home directory is located under the root directory. Is it? So this root directory is mounted with /wdb3. This is one partition. As of now, just remember this is one partition. So whatever the files and directories you are storing inside this directory, inside this means you are storing here. That will be obviously stored inside this, right? Everything will be stored in the file system hierarchy. Whatever you are storing here by default, those all files and directories will be stored inside these partitions. Your directory cannot store any files or directories. It is just keep the item numbers of that files and directories. Whenever the user is trying to access this file or trying to view that file, based on this inode number, it will display that file on your screen. This is how exactly your directory works. It cannot keep any files or directories. Your directory is just nothing but on blank field. Is just keep the inode numbers. So that data, every data will be stored inside the partition, inside the disk. So what it contains? It contains this all information of the file. Okay. Now in your system, so we already know that, right? How to manage the files, how to change the directories, and how to create the parent directory structure. Yeah, manage links. This is the important topic. Make multiple file names reference the same file with hard link and symbolic link. Manage links between the files. In our system, we can create the links between the files and directories. Okay, we can use two different type of links. One is symbolic link and another one is hard link. So the symbolic link you can call it as soft link also. You can create multiple file names that pointed to the same file. Let's say you have one file. In that file you have some information, but you decided to restrict the access for all the users on that original file, but users wants to read the data inside that file. In that case, you can create the soft links or hard link to that file, whatever the link you want. You can create the soft link or hard link to that file. Then whatever the original data you have inside that file, that data can be accessible by the all the users. That is the advantage with the links. These file names are called links. So you can create two type of links. One is hard link you can create, and another one is soft link you can create. Sometimes call it as soft link also. Each has its advantages and the disadvantages. What is the advantage and the disadvantage with it? Let's come to the board. What is the first one? Symbolic. Symbolic link, and also you can call it as soft link as well. Soft link as well. And what is the second one? Hard link. Hard link. So soft link, you can create the links between both files and directories. Users, users can create the links between both files and directories. But when it comes to the hard link will only allow you the users to create the links between the files. Users can create the links between only files. Okay, files. And hard link is always pointing to the original file. If you created the hard link between the directories or the files, so the link file is always pointing to the original file. Link file always pointing to original file, and also you can call it as source file. But when it comes to the hard link, this hard link is just like a mirror copy. It's not pointing to the original file. Okay, files are mirror copy of original file. In soft link, both original file and link file inode numbers are the different. Link and original file inode numbers, inodes and permissions are different. But when it comes to hard link, both link file and original file inode numbers and the permissions are the same. Inodes and permissions are same. Okay, these are the three major differences between the soft link and hard link. So what is the first difference? User can create the links between the both files and directories in the soft link. But when it comes to the hard link, users can create the links between the only files. In the soft link, link files always pointing to the original file. What is mean by link file? Always pointing to the original file. Let's say you created one soft link, okay, for one file. So that file is always pointing to the original file. In case unfortunately the original file is removed from the system, the link file has no value. Link file has no value. But when it comes to the hard link, in case the original file also removed, the data will be available in the link file because this is the mirror copy of the file. Both link and original file inode numbers and the permissions are the different. Okay. But when it comes to the hard link, both original file and the link file inode numbers and the permissions are the same. What is the advantage or the disadvantage here? See, let's say you have one file and the original file you have some privileges. We are expecting the same privileges for the link file as well. So if we want to change the privileges, we can change, right? But when it comes to the soft link, if you change the privileges for this link file, it will not reflect it to the original file. Any permissions, user, owner, okay, are the basic permissions. Whatever the permissions you change, it won't reflect to the original file. But when it comes to the hard link, if you change any privileges, like it is the basic privileges or the owner of the file or the group owner of the file, immediately that will reflect it to the original file as well. Okay, clear? And also you can create n number of links on the single file. Let's come to the terminal. How we can do that? Very simple. Command are very simple. ln space -s to create the soft link. Link space -s and specify your original file and link file. You can take the link file the name as whatever you want. Hard link ln, just link original file, link file. You can take the link file name whatever you want. So first try these soft links. Inside this I have one directory. This time I want to create the soft link between this directory. So what is the command? ln space -s to create the soft link and the source file. What is your source file? And what is your link file? I'm just taking the link file as link dir. This is my link file. So the link file is created. Just go with the ls space -li. Just try to observe the output. This is the link file. So what is the INO number? It is associated with it. It's something different between the both files, right? The INO number is different between the both. This is the original file, right? This is our source file. So it is the difference between both and link file. And see the file which is started with the L, that is the link file. How we can identify it is the link file? It started with the L, it is a link file. And the privileges, if you observe the privileges, basic permissions, is the privileges are the same? No, both permissions are the different. And let's see, here it is pointing to the original file, right? Here it is pointing to the original file. Let me create something inside this new project. Dir. I created some 10 directors inside this new project. Okay. So I created some 10 directories inside this new project. Let's see the same content we have inside this link file. See the same content you have inside that link file also, right? We have the same content, right? Is it? Don't confuse. See, don't go inside that directory. Now where we are inside the link dir. We have the same content. Where we created this content? We created inside the new project. The same content is reflected to your link file, right? Now, let me create something inside this link file. So I created some 5 files, file.txt. Okay. Let's get inside the project, new project. Where we are inside the new project. Let's see, the same files will be available inside the original location, right? The same files will be available inside the original directory also. This is how your soft link works. Let's say, as of now, we created the directory inside this project directory, right? Let's say this time I want to create the link, another link in the user home directory. Is the command ls space -s. This is our directory. This is our source directory. And what is your link directory? You can, if you want to give the new name, you can give, or if you want to give the existing name, you can give also. And before we give in the link dir, right? Yeah, the same. Try here. So is it created? The same. Sorry. So the same link dir is created in the user home directory. Let's go with the inode number. This is something inode number. Both are not same. Right? Here also it is pointing to the same directory. Right? Pointing to the same directory. Now verify the content. Before we created the content inside the project directory, this time you have the content. Let's create something inside this. Link dir. Oh, this content. Okay. Let me create one file. File 100. I'm just taking the file name as file 100. Try to understand this. Where I'm creating this file, link dir. Where this link dir is located? Inside the user home directory. Okay. Touch file 100. We created the file 100 inside the link dir that is located in the user home directory. And this is pointing to the original directory, that is new project. New project. Okay, let's get inside that new project. Do we have the same file, file 100? And also, before we created one soft link. So is that file is reflected there? Just verify that. You have the same file, file 100 is reflecting here. So wherever you create, whether if you are creating in the link directory or the source directory, it will reflect it to the all the link directories. Clear? Now this time what I am doing, as of now these files and directories are pointing to source directory. This time I am removing the source directory. Let me remove that. New project. I remove. Just go with the ls space -l. This time what it is showing? It is showing different, right? Before it is showing, it is pointing. This time also it is pointing. But do we have that file is existed? No. It means the file is not existed, the source file. This time try to access the content which you have inside this link dir. Try to get inside this link dir. What it is showing? No such file or directory. But this file is showing that, right? Is this file is showing, but are you able to accessing this? The same way you have the same file in the user home directory. So this one you can able to access, just try it. Are you able to access it? No. The original file is deleted, there is the no value of the link file. Okay. The same way you can create the content between the files as well. Okay. Let me do that. Project. Okay. This time I'm just creating, as of now I don't have any content. I'm creating one file. The file name I'm taking as documentation. Okay, this is my file. So let's add some content inside this. Okay, let me add some content. Web server running on port 8080 container. Okay, this is a simple content I added. So let's save this file, document So you have that content, are you able to reading that content, right? Now try to create the soft link. ln space hyphen s. This is our source file. But what about your link file? Link, you can take any file name. I'm just for example purpose, I'm taking the link. You can take any file name. Link file. Okay. So just hit ls-l. Is it created the link? Right? Try to access the content inside the link. Sorry. Are you able to reading the same content? Let's modify the content inside this link this time. Let me add one more line. Web server running on port number 8080 in container. Forward the request. Port 80. Okay, I just added the simple content. Now where you added this content? In the link file we added this content. Let's view the same content inside that link, sorry, original file documentation. Are you able to reading that content? Let's say this time I want to create the another link for this file, okay, in the same directory. In that case you want to take the different name. Okay, this time what I am doing, I am creating the soft link for this link file. Understand that before we created the soft link for the source file, but this time I am creating soft link for the link file. How we can do that? Same link file and take the file name. If you want to create the file in the same directory, you can take the another file name. But if you want to take the same name, create in the different directory. Okay, by default your directory won't allow to create. Or if you want, you can just change the letters also. Okay, in the place of small, just specify the capital. Link hyphen file. It's allowed because here the characters are the different. See, here you have the two soft links. Just go with the ls space hyphen l. So this time, what is the source file documentation? What are the link file you created? Link hyphen file we created. That is the first link. And after that, for this link file, to this link file, we created another link. Let's try to access the content on this link file. Are you able to access in the same content? If you modify the content, it will reflect it in our link file. Let me remove the source content. Documentation, let me remove. See, but here, is it showing it is like a original file, right? Just remove the content. Go with the ls space hyphen l. So, the link file pointing to the original file. The original file is documentation. Here, the link capital I, capital L, link file is pointing to the link file. The link file forwarding the request to the source file. The same way, this link file forwarding the request to the link file. So in this link file, you don't have any content by default. It is just taking the content from this documentation. The same way, this link file also not having any content inside this. It is also taking the content from this link file. But how it is worked before? Because before this link file serving the content from this documentation. This time, this documentation is not available. So this link file obviously not having any content. So it cannot provide the content to this link file also. Don't confuse. Clear? Now, on to the hard link. So let me create one directory. The directory name I'm taking as ex200. Okay, rhcsa rhcsa version 9. I'm just taking, this is my directory name. This time, try to create the hard link between the directories. Okay, for the hard link we are using ln link, that's it. And what is your source? rhcsa version 9 is my source. What about your destination? What is it? And what is your link file name? Just taking hard, you can take anything. hard hyphen link I'm taking. But what it is showing here? What is the output it is generated? Link not allowed for the directories. Here you are getting some error, right? But how we can analyze that about the errors? Just type echo. This echo is a command. It will just print the message. Whatever you are passing in your terminal, it will just print that message. Let's say I am just passing as hello Sai here. Yeah, this is just one simple message. I just want to print this message. That's it. Is that message is printed, right? The same way, I just want to save this output. Whatever the output I am getting, I want to store that output into different file. So in that case, we can use the redirection sign. Provide your file name file.txt. That is the file name. So the file is created, but here if you use the environmental variable echo $sign and the question mark, here it will generate the number, one number. This is the error codes we can call it as. There are some 350 or 250 error codes are there. In the Red Hat Enterprise Linux or related distribution, you cannot see these error codes. Okay, by default, they will give you only three different type of error codes. When you hit the $sign and the question mark, okay, this give you a number. In this case, it is 0. It means your input is successfully executed. Whatever the previous input you assign to your system, that input is successfully executed. Let's say, let me create one directory. I just created this directory. So here I am not getting any error and also I am not seeing any output. But I just want to know whether it is executed successfully or not. As per the system perspective, not for the user. For the user you are using ls. But as per the system perspective, how your system is analyzing that based on these error codes. 0. It means it is successfully executed. Now this time I am making something. So here what we get? We get some error. This will see how your system is calculating this error. This will see in the next chapter. As of now, just remember this error codes. In this case, I'm using $sign question mark. This time is generated the number 127, right? If it is 0, the input is successfully executed. If it is 1, it is a minor issue. If it is 2 more than 2, it is a critical issue, right? This is how your system is calculating your outputs. But how your system is taking the input, that is the different. How your system is sending the outputs to your terminal, that is the different. That we'll see. So it's not allowing to create the hard link between the directories, right? It's not allowing, right? Try to create with the files. As of now, do we have any content inside this file? Yeah, we have the content. Try to create it file.txt, and you can take the file name whatever you want. Hard hyphen file. I'm just taking this file. This time go with the ls space hyphen here. See, this is the link file, right? This is the hard link file. This hard link file is pointing to the any other file. Is it pointing to any other file? No, it's not pointing to the any other file because it's just like a copy. If you observe this, the both file inode numbers are the same, and also the both file privileges are the same, right? Let's say if you modify the content in any one file, it will reflect it to the another file. This time I am changing the permissions of the link file. Chmod 777. See, I changed the privileges for the link file, but is it reflected on the original file? It's reflected to the original file, right? This time what I am doing, I am creating one more hard link for this link file. Remember that I am creating the one more hard link to the link file. If you created the original file, okay, it always point, but this time I'm creating to the link file. Let me do that hard. What happened to the system? Hard file. Want to create the link file in the same directory, we want to give the different name. File link. I'm just taking this file. So just go with the ls-i. Just observe this. Is the inode numbers are the same for the three files? Is the inode numbers are the same? 150 ended with the. Our original file is file.txt, and this is the link file we created on this original file. And after, sorry, this is the link file we created, right? This is the link file we created on top of this file.txt. On this link, we created one more link. So the data which you have inside the original file, or if you modify the data any one of the file, it will reflect it to the all files. Okay, let's read the data from any one of the file link. So we are able to reading the data. Okay, let me add one more data.
Sai, from the file, how to know which is original file, which is the link file?
That is the reason, right? You cannot identify. See, in the hard link, you cannot identify that. You should remember. That is the mirror copy of the file. In the soft link, you can identify, but in the hard link, you cannot identify that. Let's see. Here you can understand that. File-link. So we have this data. So this data is reflected to all the files. Let me show the data in the file.txt as well. Is it reflected? Let's remove the original file. We removed the original file. Let's try to read the data from the link file. Are you able to reading that data? Yes. And also we created one more link add. Are you able to reading the data? Yes. Right. So in case the original source file is removed also, you can able to read the data. That is the advantage with the hard link. If you want, you can create the number of hard links for the links. All are pointing to the only one inode number. Whatever the data you have inside that inode number, it will display to the all the files. Clear? In the hard link, you cannot, once you created the link, you cannot identify the what is source file and what is link file, because it's not pointing to the any file or directory. If you observe this, here these files are pointing to the source file. These are the link file, right? Soft link file. But here you created the two files, two link file. These files are any pointing to the original files? No, these files are not pointing to the any original file. So we cannot identify that. You cannot identify which one is the source file and which one is the link file. This is how your soft link and hard link works. Okay. See, not only in this directory, for example purpose, I taken these file names and in this directory. You can create from any directory. Okay. And also, let me show you one more thing. See, here I have one directory. The directory name is project. Okay. I don't want this one. So the directory name is project. What is the inode number of this project? Something it is 17183146. Okay. Sorry. Let me do one thing. Just give me a moment. Okay. See, I have this project directory inside my user home directory. It is inode number 178341. This time what I am doing, I am copying this file to inside this soft link. Okay. So before you have the project directory inside the user home directory, that time this is the inode number. But while you copied this directory to some other location, not only directory file also the same. If you copied this to some other location, is it changed the inode number? Right? You copied, we are not moved, just copied. Is it changed the inode number? Is it assigned the new inode number? But how it is getting the inode numbers? See, this is the partition I have. This directory, I copied this file, right? But the soft -link, this directory, I copied this file. So what is the file system is formatted with this directory? It is something ext. Okay. Based on your file system, it will assign the inode numbers to your files and directories. Let me remove this file from this location. So we don't have any content. This time, let me move this file. Move project soft. This time, please assign the new inode number. Right? If you're copied or moved, we assign the new inode number. Let me do one thing. So the directory is in root user home directory. This time I'm just moving this directory to root directory. Just try to understand. Oh, we already moved that, right? Let me copy that directory soft project to slash project. Yeah, this time is it assigned the different inode number, right? It's assigned the different inode number. Let me remove and move it. Move. See where your source file is locating. My source file is locating in this soft. This is the directory. And what is your file name? Project is my file name. Where you want to copy? I want to copy to my current location. In this case, you can specify the complete path or you can use the dot. Dot represent current directory, right? Just copy it. Do you have that file? Let's specify. This time, is it assigned the different inode number? Right? In this way, you can use your files. The same I am doing, I'm just copying this file from this location to root user home directory. Okay. Just assign the different inode number for this. Right? Let me remove and move it. This time new inode number. Every time you are copying or moving that file or directory from one location to another location, it is changing the inode number of that file. Okay. It cannot keep the same information. It's changing the inode number of that file. Okay, clear? This is about your links. Clear? Are anyone having any questions on these links?
In our environment, if someone accidentally remove that links between the file and directory, can we retrieve it?
Once data is removed, it cannot easy to retrieve the data.
Any soft link or hard link?
Anything,
Anything.
whatever the file you remove from your system, it's cannot easy. Unlike your Windows, it is not stored your bin. Once the data is removed, that's it. You can forget about that. If you want to retrieve the data, there is a separate process for that. That is different. That is completely different to retrieve the data. If you remove the file in your Windows, directly it will go to the bin, recycle bin. But here it will not go to any bin. It's directly removed from that system.
In hardlink, every time we change the path, it is the same inode number.
The inode number is the same.
Any path.
Any path, you can take any path. See, you can create hard link any directories. The same directory, if you want to create the number of hard links, just change the name. If you want to create in the different directories, you can take the same name.
Inode number.
Same inode number. Inode number will not change for the hard link. For the soft link, it will change. So, and one more thing, just go with the time. So, what is the time now? As of now, my time is 1854 IST. I want to change my time zone, but from where I am getting this time? So in your system, by default, we are getting the time from the NTP protocol, network time protocol. This network time protocol syncs the time between your server and your client. Let's say one simple example. You have one application that is running in the server. That server is located in some other region, not in India, like North Virginia. That server is running in the North Virginia region. There we have the different time, that is the UTC or something is there, GMT. So we are living in India, our time zone is IST. I want to sync the time between my application server and my client server. The application server is located in the different region. My client server is located in the different region. I want to sync the time to application, and in that case, what we are doing, we are syncing the time with the NTP. So by default, NTP protocol is active and running in your system. Just go with the cronny dot service, crondy, crondy dot service. As of now, just remember this command. One way is you can sync the time with the NTP protocol, and another way is you can change the time manually in your system. If you want to change the time manually in our system, first we want to stop this NTP protocol. The NTP is running, it won't allow you to modify the time. So first we want to stop this. As of now, just remember how to use the systemctl command. We'll discuss it. Stop cronny d dot service. Stop this service. After that, go with the status again. So this service is stopped. Now we want to change the time. How we can do that? Time date CTL. Command is time date CTL. So when you hit the time date CTL, it will give you your local time, universal time, RTC, and time zone currently you are using. Okay, system clock synchronized and NTP service status and everything. So now NTP service is in inactive. If the NTP service is in inactive state, then you can change your time manually. The NTP service is in active state, it won't allow the users to change the time. Okay, now how we can change that? See, as of now, my time is something 8:56. I want to change time date CTL. Okay, set hyphen time. That's it. Set hyphen time. Whatever the time you want, you can just specify that. I'm just changing the time as 10:15. Okay, just hit it. Whatever time date CTL. So is the time is changed? Remember, when you change the time, whether you are changing the time in the local time, you are changing the local time. When you change the local time, automatically universal time will be changed. Okay. This time I want to change the date. To change the date, we are using the same command, time date CTL set hyphen time. Okay, set hyphen time. So the format you can use whatever you want. I am taking 2023 01 01. Just go with the time date CTL. So is it changed that date? Based on this date, these dates also changed and also time also changed. Here you just specified what you specified. Here you just specified the 111. Are you specified any time? No, you are not specified any time. So that is the reason by default it takes starting from 00. Right? Go with it. Is it time is changing? Right? We have the same time here. See guys, don't observe this one because this is my host operating system time. Okay, this is my virtual machine. Don't confuse. Here we have the 1853, but here you are showing the 00. Don't confuse that. This is my host operating system time. This is my virtual machine time. Now this time I want to change my time zone. To change the time zone. As of now I have Asia Kolkata. I want to change it. To change the time zone, first we want to go with the list of the time zone. Time date CTL list hyphen time zones. Just use the tab. Automatically it will complete your command. So just go with the list. Here you can use your navigation keys. Let's take any one of the time. Okay, I'm just going with the America, New York. Okay, how we can do that? Just copy it. Guys, after the selection, if you want to copy anything in your system to the command line, use Control Shift C to copy. After the selection, if you want to paste it, just use Control Shift V to paste it. Okay, now how we can set this time? Time date CTL set hyphen time zone. Just paste it. Either you can use your mouse to paste it or you can directly use the keyboard keys to paste it. Now go with the time date CTL status. Is it changed the time zone? As per the time zone, is it changed the time as well? Right? As per the time zone, is it changed the time also? In this way, you can use your time date CTL command. But here in this topic, you will get one question in your exam. That question is the very simple. They will give you one NTP server name or IP, whatever they are given. One NTP server name or IP they will give you in your question paper. So you just copy that name or IP, whatever they given. After that, open this configuration file. This is the configuration file for your NTP, chrony.conf. Chrony.conf. This is the configuration file. Just open this configuration file. See, once you open this configuration file, inside this configuration file they will give you different things. Suppose here you are seeing this server, right? But in the place of server sometimes they will give you the pool. But what many people doing, here we have the pool, they are specifying the pool, but don't do that. So don't touch anything inside this file. Everything is commented. Just remember one thing. This is the configuration file. In any configuration file, the line which is started with the hash means the line is commented. It means the line is not going to execute. Once you uncomment this line, then will line going to execute. Remember that. Well, moving forward, we'll work with the different configuration files. The line, anything is started with the comment hash, it is not executable line. Okay, if you want to execute that line, remove that comment. So what we want to specify? By default, specify the server because you are syncing the time from the server, not from the pool. Pool in a sense bunch of servers, but we are not syncing the time from the bunch of servers. We are syncing from the only one server. Specify the server and IP. If they give you the IP, just specify that IP. If they give you the name of the server, just give the name of the server. For example, I am just giving the IP, and by default ibus parameter must be enabled. Ibus, that's it. Just save this file. Okay, that's it. Just save this file. After that, use cronny c sources space -v. When you hit this command, see, this command will work when the NTP service is running. Okay, as of now we stopped the NTP service, right? It won't work. After that, once you hit this command, it will show you whatever the IP you added. Okay, it will just show you the whatever the IP you added in the system. That's it. This is about your NTP.
So Sai, like during the exam, again we need to recycle that crony service, right? After modifying the configuration,
No, no,
or
no,
it's
not at all.
crony sources hyphen v is enough.
Only sources -v. No need to
Okay,
restart the NTP service.
okay, okay.
Yeah, anyway, we'll discuss it in the exam preparation, no problem. Okay, let's say here I have one file, anaconda-case.cfg. That is one configuration file. Let's open this file. Inside this file, we have many keywords, right? We have version, RHEL, we have the system, bootloader, many keywords we have. Okay, I want to match the keyword inside the file. Let's say I have one keyword. I have the keyword called root. This keyword I have inside the anaconda.cfg file. Not only that file, any file. I want to match this keyword inside that file. I want to know how many lines we have this keyword. This keyword we are calling as a string. Match the string. How we can do that? With help of grep, we can match the string inside the one file or more than one file. We can match the one string or more than one string. Grep. Grep means global regular expression. Okay. Global regular expression. It will help you to match the string from the one file, more than one file. So grep and specify your keyword, whatever the keyword you want to match. I want to match the keyword as root. Okay, from where you want to match, specify the file name. From this file, I want to match that keyword. See, is it matched that keyword? Right? Is it matched that keyword? Now this time, here it is showing only small letters, right? Lower cases it is showing. But in case if you have any upper cases, it won't match because Linux is a case sensitive. Whatever you specified, it will execute that as is. Okay, that's the reason it is showing only lower cases. In case if we have any upper cases, then how we can find that? For that, use -i, case sensitive -i. When you use the -i, irrespective of the case, whether it is the upper case or the lower case, it will match the string which is root. So this time, sorry, is it matched the string? Uppercase also, right? It's matched. If you observe these outputs, sometimes some lines are starting with the root and some lines are ending with the root. Not only root, you can take any keyword. Okay, starting with the root and some lines are ending with the root. This time I want to match the string root which is starting of the line. You got it? I want to match the keyword called root that is with the starting of the line. So in that case, we are using the cap sign for your string. This is my string. Okay, here we are using the cap sign. Cap, some people call it as a caret sign also. Okay, once you hit the enter, it will display the lines which is started with the root. The same way, this time I want to match this root keyword which is ending of the line. In that case, we are specifying $sign. To ending of the line, we are specifying the $sign. See, is it matched? The ending of the line, right? It's matched. Okay. And we have some other keywords also there, right? Let me open that file once again. System version loader. Okay. SE Linux. Okay. This time I want to match the two keywords from this file. How we can do that? Grep -e. Now more than one keyword, we want to specify the -e. Okay. And what is your keyword? My keyword is the root. See, here we are not specified whether we want to match the keyword which is starting of the line or ending of the line. If you want to specify that, use the caret sign for the beginning. For the ending, use the dollar sign. Let's say I want to find the keyword root which is beginning of the line. And also I have one more keyword, that is SC Linux. For the SC Linux, I am not specifying anything. Okay, then in between the line also it will match. From where you want to match? From I want to match from this file. Is it matched the both keywords? It's matched the both keywords, right? Likewise, this time I want to match the keyword version. Okay, I want to match the keyword version. If you want, you can specify the singular double quotations also. That is also not a problem. Let me take one more keyword. Root. For your clarification, if you want, you can take the quotations also. See, here I am finding the keywords version, SC Linux, and the root. Oh, here we are using the cap. It means it is match only beginning of the lines. And also, let me take one more keyword, RHL. Let's see, we have any keywords. RHL. That too with the ending of the line. Okay. But here in this case, I am using the case sensitive. When you use the case sensitive, here it will find both uppercase and the lowercase. Just hit enter. See, is it matched? Sorry, something wrong. Let me remove it here. Just hit it. But matched only three keywords, right? One is version, and another one is SE Linux, and the root. We don't have any keyword which is ending up the line. So let's find any line with the ending. I think we have the root. Okay, root. So this time, is it matched? Right? Here we are finding only from the one file, right? Let's say we have the another file also there. We have another file is original.ks. I want to match the strings, whether it is the one string more than one string. Okay. I want to match the files from the string from the two files. One is Anaconda and another one is original. Space and specify your file name. Likewise, if you have the number of files, specify the number of files. So when you hit the enter, is it displaying this output on your terminal? Right? See here in this case, in this example, it is finding the string from the anaconda.cfg and as well as original.cfg. I don't want to display this output on my terminal. I want to store this output into your file. In that case, use the redirection sign. So redirection sign, whether single or double, whatever you want you can use, and specify the file name. Okay, I'm just taking the file.txt. So is that output is redirected to this file, right? The output is redirected to this file. Let's say this time I want to find these strings from three different files, and this is my third file. Okay, this is my third file. So just hit enter. See, is it matched from three different files? Yes. Original.cfg, file.txt, right? It's matched from three different files. In this way, you can match your strings. That's your strengths.